Right, we got OSPF running between router 3 to router 10. And we know one rule. Every area should be connected to backbone.
Right.
In our case here, area 30 is newly added network, and you have just connected to router 3. Area 30 you have connected to router 3 because there was no ports available on router 5 or router 8, or you don't have a cable to connect to area 0. For time being, you need a solution. You want area 30 to be connected to area 0, but physically connecting is not possible. OSPF has got an option. You can put a virtual connection to R5 from R3. R5 is a part of area 0. It is an ABR. So you can make a virtual connection between R3 and R5, using which area 30 can directly deliver the updates to area 0. And area 0 will replicate it to area 10 and area 20. Area 30 cannot share the update with area 10, even though it is a very adjacent area. Area 30 should use the virtual link, deliver the packets to area 0, deliver the updates to area 0, and it is only area 0 that can give the update to area 10. That's what we are going to see. So we have OSPF already running between R3 to R10.
Okay.
If you want, I can ping and show 10, 10, 10, 10, which is the loopback of router 10. Resource 3, 3, 3, 3. I'm able to ping, which means there is a convergence between router 3 and router 10.
Right.
I can also trace route. You'll see traffic going via 4, 5, 6, 7, 8, 9, and 10. So meanwhile, what I'll do is I'll go to router 2 and put the necessary configuration.
Router 2 or router 3?
Router 2. Router 3 is tracing right now. I don't want to disturb. Router 3 is tracing route to router 10. You see? So I don't want to disturb.
Yeah. Okay.
So this router 2 is IP OSPF 1 area 30.
Oh, okay.
Interface Ethernet 0/1. IP address is 10.30.23.2. IP OSPF 1 area 30. And I got another physical interface 10 Ethernet 00, which is 10.30.12.2. IP OSPF 1 area 30. And next is, I'll go to router 1 here. Router 1. Let's go and check whether the trace is done. Yeah, you can see that it goes to router 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9. So OSPF is good between router 3 to 10. Now on router 3, I got another interface called E00, which is supposed to be a part of area 30. IP address is 10.30.23.3. IP OSPF area, IP OSPF 1 area 30. You see, show IP OSPF interface brief. You can see the IP address correctly given, and then it is a member of area 30. Now you also see a neighborship between router 2 and router 3. This is the router ID of router 2.
Right.
So router 3 should have two neighbors. Show IP OSPF neighbors. There are two neighbors. One in area 10, another one in area 30. Show IP OSPF interface brief. You can see this is in area 10.
Right.
This address is in area 10. Okay, now I'll move to router 1. One. IP OSPF 1 area 30. Interface Ethernet 00. IP address 10.30.12.1. Yep. So we are expecting neighbor between router 1 and 2 now. Okay, you got it. But you see, I can ping 3333 if only I get route
Right.
from area 0. Because router 3's loopback is in area 10. Area 10 cannot give directly to area 30. See, I can ping this address, which is 10.30.23.3. I can ping. You see, this is in same area. Ethernet 0 is in same area. I'm able to ping. But on the same router, this interface, I'm not able to. I cannot ping. The reason is OSPF is not giving. Router 3's loopback is in area 10. Area 10 routes cannot come directly to area 30. It needs the backbone support. So area 3 should have direct connection to backbone. Unfortunately, we don't have a direct connection. At least a virtual connection we need to make now. So if you check the routing table now, show IP route OSPF, you don't see routes for the networks which are in area 10, area 0 and area 20. Which means this area 30 is not a part of that autonomous system. Isn't it?
That's correct.
Area 30 is discarded from OSPF autonomous system. Area 30 has got no connection, nothing learned from area 10, area 0 and area 20. It is because the hierarchy design OSPF follows. Every area should be connected to the backbone area. Now, fine.
Okay.
How can I put a virtual link? For that, you need to know the router IDs of router 3 and router 5. I repeat. You need to know the router IDs of router 3 and router 5. Go to router 3 and find the router ID. What is the command to see the router ID? Show IP OSPF. Show IP OSPF. You see, the very first line will show you the router ID. Do you follow me?
Yes, sir.
On router 5, show IP OSPF. This will also show me the router ID. Fine. You need to take this router ID to router 3. I'll go to router 3 and now I'll say router OSPF process ID. Which one is going to be virtual link? Area 30 need to be a virtual link. Understand very well. Area 30 need to be a virtual link.
Okay.
Are you going to make area 10, sorry, area 10 is going to be the virtual link for area 30. I repeat, area 10 is what should act like a virtual connection between 3 and 5.
Right.
So I need to say virtual link, area 10 is a virtual link. Area 10 is a virtual link. I'm in which router now? Router 3. So router 3 will automatically take, are you listening?
Yes, sir.
Router 3 will automatically take its own router ID as a source. Now you need to provide the destination router ID to which it needs to negotiate. So it's going to negotiate with R5. 5.5.5.5. Likewise, I go to router 5 and say router OSPF1 area 10 is a virtual link. What is the router ID to which it needs to negotiate? 3333.
3.3.
After I hit enter, this error will go away. Shall I hit enter?
Yep.
Boom. Now you will see a new neighbor coming. Look at this. A new neighbor, router 5 is saying, I got a neighbor. Who is that neighbor? 33333. What does this prove you? This proves that area 5 has got connection with area 30. This proves that backbone is connected to area 30 or area 30 is connected to backbone. What is the link name? Is it fast Ethernet or Ethernet?
No.
It's virtually. Let us check this. Show IP OSPF neighbor. Tell me how many neighbors I'll see.
What's 5?
Hmm?
3. 3.
Yeah. 3, one is with virtual link. And you see for virtual link there is no DR-BDR election.
Right.
It seems like serial link. The priority is always 0 and full adjacency. Now go to router 3 and you can see another neighbor. Now let's check show IP OSPF neighbor. You can see here via virtual link 5555 is a neighbor. Router 5 is an ABR. As a result, if you go to router 1 now, earlier you did not see any routes from OSPF, autonomous system. You are only seeing local, but now you see all of them. All of them. Earlier you were not able to ping this 333, but now you can ping.
Right.
Let me continue the recording. It's already recording. I have forgotten to pass it. It's okay. So we got a virtual link between R3 and R5. If I try pinging 8888, I should be pinging. No problem. It goes from R1 to R8. It can also go from here to 10, 10, 10, 10. It can go to any area from here because the updates we have already received through the virtual link. See, it's only the updates that goes from R3 to R5 area 0 and ABR takes from our area 30 and gives to area 0. R5 takes from area 30 and gives to area 0. and area 0 takes it and gives to area 10. It's only the route update. But the packets,
Okay.
they don't need to go to area 0 and come back to router 4. If I ping, it's going to straightly go to router 4. It will never go to router 5. But the reachability to
Okay.
reach 1111 was given by R5 to R4. The reachability was given by R5 to R4. Now, we are going to make this area as another autonomous system now. I'm not going to run OSPF. I'm going to make another autonomous system, maybe EIGRP. 10.
Okay.
So we will take EIGRP roots and we'll give it to OSPF. Router 3, show run interface Ethernet 00. I'm cancelling this OSPF. No. Done. Instead, what I'm going to do is I'm going to run EIGRP router EIGRP 10 and network 10.30.23.0 000.255. So this is going to run EIGRP on this link, isn't it? 23 is on this link. Likewise, I'll go to router 2. I want to remove OSPF. The easiest way is no IP routing. When I put this command, the routing protocols gets removed. And I put it back, the command, so that I can have new routing protocols. I want to verify show IP OSPF interface brief. You see, there is no interface in OSPF.
Right.
I cancel the routing process. When I do that, all the commands that I configured earlier related to OSPF got removed. Now let's put EIGRP router, EIGRP 10 networks, or this networks, all that starts with 10.30. I'm expecting a neighborship, yes. Between router 2 and router 3, there's a neighbor. Show IP EIGRP neighbor. You can see that. Show IP EIGRP interface. You can see EIGRP is running on all this 3 interface. Now let's move on to router 1. Same way, I'm going to remove SPF by saying no IP routing. And then I'll put back routing. And now router EIGRP 10 network. Network, anything that starts with sender 30. All right. So again, I'm expecting neighborship. I do see it. Now, can I ping this address? Not possible. Same like before. Before the virtual link URLs, you were not pinging. That time you were having OSPF, still you were not pinging because of the adjacency was not an area 0. But now I am not able to ping because the protocol itself is different. Protocol itself is different.
Right.
I can ping 10, 30, 23, 3. But I cannot ping anything in OSPF domain. I can ping all those that are in EIGRP. If you check the routing table, show IP route EIGRP, you can see the routes coming from router 2. And this is the network between router 2 and router 3. Now on R10 in router 10, when I check the routing table, I will not have any information about the EIGRP domain networks. Show IP route OSPF. There is no information about 2.2.2.2. I see only 3333. And there is no information about 10.30. Nowhere you have 10.30. So what is the solution? We don't have OSPF there. It is only EIGRP. Solution is redistribution, isn't it? Router 3 runs both OSPF and EIGRP. We need to redistribute from EIGRP to OSPF and vice versa. OSPF to EIGRP. If you want R1 to know about OSPF networks, you have to do OSPF to EIGRP. But before I do these things, I would like to introduce you to that LSA types. Right now, I don't have any external. Right now, in OSPF, are we learning EIGRP routes? No. Which means I will never see type 3 and 4. Sorry. I'll never see type 4 and 5. I'll never see type 4 and 5. Why? Type 4 brings the router ID of ASBR. Type 4 brings the router ID of ASBR. Do we have ASBR?
Yes, we do have an ASBR number 3.
No, we have not still redistributed. As right now, do we have ASBR?
No.
So when you try to see the database, you will never find type 4 and type 5. Both will be missing. Will I see type 1? Yes. What is type 1? Type 1 is router LSA. Type 1 is router LSA. This LSA comes from every single router. But what is the scope of router LSA? It is local to the area. Do you agree? Can you recall those things we learned?
I didn't hear you.
Router LSA, what is the scope?
It's just local to the area.
It is local to the area. So how many router LSA entries I'll see in R10? How many lines? Or how many LSAs I'll see? How many?
Three.
Yeah. But only 2, no? Local. When I'm checking on R10, I will see router 8 and router 9. Show IP OSPF database, you see. Router 8, this is what? Sorry, not this one. This is what? This is what? Router 8, which is in area 20. Router 9, and the local one.
Right, that said 3.
3. Okay. So its own. I mean, router 10, it shows its own.
Right.
But learned is 2, no? So anyway, hey, what you said is correct because my question was how many you will see. Not how many you learned. Okay, fine. You got. And Each link will have a DR. Now there will be two DRs because we have two links. One is local itself is a DR. Another one, router 8 is a DR. Router 8 is a DR and router 10 is a DR. Those are the advertising routers.
Right.
The advertisement is coming from the interface 9110. But what is the router ID? Router ID is this 10, 10, 10, 10. This is the IP address of router 10. And this is the router ID of router 10. This is the IP address from where the packet comes out, which is router 8. And this is the advertised router's router ID. Now,
Okay.
summary LSA will bring the updates, link state updates from other area. So if you see summary LSA, it is your router 8. Router 8 is the one which brings the other area routes. Starting from
Right.
333 to 888, and then 56 is between 5 and 6, 67 is between 6 and 7, and 78 is between 7 and 8, and 34 is between router 3 and 4, which is in area 10. 45 is between 4 and 5, which is in area 10.
Right.
You don't see 10.30. You don't see 10.23. You don't see 10.30.23 or 10.30.12 or 2.2.2.2, 1.1. It is because we don't have redistribution on R3. But when I redistribute, will I see 10.30 here in type 3 LSA? No. 10.30 will be seen in which type? 5. Now what will be LSA type 4?
Type 4 will carry
3.3.3.3.
Right, about that's the ID.
Okay.
Right.
So we are going to check those things after we configure on R3 the redistribution. I'm in router 3. Router OSPF 1. Redistribute EIGRP 10. And then subnets. I hit enter. Likewise, I'll go to router EIGRP10, redistribute OSPF1 metric, the K values. Yeah?
Okay.
Alright, if you're okay, then we'll go to router 10 now. When you go to router 10, now you will see type 4 and type 5. Let's see. There is no change in type 1. There is no change in type 2. And there is no change in type 3 as well. But you got additionally autonomous system border summary LSA, which is bringing the router ID of ASBR. Now, who is giving you? Your ABR will give you. If you check this output on router 7, what will be the advertised router? If I check the same output on router 7, what will be the advertised router? Who will be advertising you type 4? The ABR, which is R5, 5555, isn't it? Let me show
Yes.
you. R7, you see. Show IP OSPF database. You see, 5555 is advertising you. But when you check the same thing on router 10, it will be router 10's ABR, which is 8888. This is
Okay.
router 8.
I see.
So it is the ABR which redistributes that. Every border it changes the advertised route. Now, type 5 LSA brings all that is there in area, not in area. It is in area. It's from EIGRP 10. These are all
Right.
external. But when you check the routing table, you will see very clearly E2. Show IP route OSPF. You can see here E2 means external type 2. Type 2 means
Right.
pathcast should not be added. We'll talk about that in the coming class. E2
Okay.
means they are not from OSPF domain, they are coming from some other source. In our case, it is EIGRP. Likewise, if we go to router 1, you will see OSPF as external. Show IP route EIGRP. These are all external. All the OSPF networks are seen as external. That's EIGRP. Let's not focus on that now. But one thing I want to just remind you, if it is external, administrative distance is 170 for EIGRP. Otherwise, it will be 90.
Right.
You see, here it is 90 for EIGRP's network. And for all OSPF network, it is 170 because it's a redistributed. So on OSPF database, we see type 1. I'm looking into router 7's database, which is in area 0.
Mm-hmm.
In router 7, I see 1, 2, 3, 4 routers, but I see 5 entries. You know why? Because one is a virtual link. We also have connection via virtual link 3333, isn't it? Router 5 is also having connection with router 3.
Okay.
So in the database, router 3 is seen as area 0 member. That is why you see under router. That is what virtual link, right? We still didn't remove the virtual link.
Right.
Please understand, I have not removed the virtual link. That's the problem. That's why you see that. I'm going to remove that. I did not remove because I want to show you this in the database. All right, I just want to show you how real it is when you form a virtual link. Even the database thinks that router 3 is inside the area 0. So
Right.
let us go and remove the virtual link that we created earlier. Show run section router OSPF. And this virtual link I have to remove. I'll also remove from router 5. All right. Now, going back to router 7, I should not see this line. You see, it's gone. Oh, it's still there. Oh, you need to wait. I'll refresh OSPF here. Clear IP OSPF process. But it's going to be disruptive and we should not do this. Now to get the latest one, I did this. Go back to router 7. It's still there. It's still there. It may take some time to refresh. Let me try again. Clear IP/OSPF process here. Show IP/OSPF database. No, I still have it. Why this keep on coming when I don't have? These are all okay. These are all type 5, must be seen.
Right.
Okay, it's that, when you restart the entire stuff, it'll go. Let us not focus on that. Now, LSA types, what we learned and what you see here should match. We learned that the router ID of ASBR will be carried by type 4 LSA. The EIGRP routes that are coming in should be carried as type 5. We see that. And all the routes that are coming from other area should be seen in type 3. This is all coming from other area, not from EIGRP. And all the DRs should be seen here. How many DR you will have? For each link you will have one DR. So I got 3 links. 1, 2, 3, 3 links. So you have 3 DRs. And then this is type 1, again coming from every single router. Type 1, the member of area is 0. As of now, the member of area 0 is only 4. Just ignore this one. Ignore this one. We don't have any more virtual link. Or maybe I should refresh on R5 as well. Let me do a refresh. R5 is already refreshed. Why am I still seeing it? We'll go to route 7 and check it again. Again, it's coming. When we restart, it will go away. Yeah. See, the age is still same old age, 5. It never increases, which means there is no fresh update. It's incremental backup. It's incremental update. So, what is next we are going to see is about the summarization in OSPF, and then E1, E2, those stuff, and then we'll get into special area types. Special area types like stab, totally stab, not so stab, totally not so stab, etc. Okay, we'll stop here for the day.